Okay, here we are on the second page. Fill in the blanks for the two-column proof. The sides of a rhombus are parallel. So if you draw a rhombus, and it looks to me like it's going to be A, B, C, D, like this, and these guys are all congruent. That's the definition of a rhombus that you should know well. And we're trying to show that these are parallel. These are parallel like this, and these guys are parallel like that. The only way we can show things are parallel is the converse of our transversal rules. So if I draw CA right here, that's what that's suggesting. It's going to be congruent to itself because of the reflexive property. And AB is going to be congruent to CD because that's the definition of a rhombus, that all the sides are congruent. DA is going to be congruent to BC for the same reason, definition of a rhombus. Always remember what those definitions are so you can apply that. That's a triangle symbol there, not a very good one. But triangle ABC is going to be congruent to triangle CDA. CDA, whoops, I wrote it in the wrong place, that's funny, CDA, because of side, 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 okay? I've got three sides congruent to three sides. Even though these two are the same, that doesn't mean that between the two sides, as I noted in my proof, that's why we do these, that is true. Anyway, angle ABD, angle ABD, whoops, CDB. Yeah, that's not the right angle, I'm sorry. That should be angle ABC. That's this angle right here, is going to be congruent to angle angle AB, whoops, nope, it's not even correct. Alright, fun of doing things live. BAC. BAC is going to be congruent to DCA. DCA. And that's going to be because of CPCTC. Alright? And I have proven the triangles are congruent, so I can say these corresponding angles are congruent. That's a key thing for you to know. Then I can say finally that AB is parallel to CD because of the converse of alternate interior angle theorem. Okay, now this is the key thing. If I see AIA there, that'll be good, but even better if you tell me that it's the converse, or going in the opposite direction. Okay? Then this next one is given the diagram and the fact that C is the midpoint of AD and BE, prove that this angle right here, angle A, is congruent to angle D. Alright, no typos here. I think it's pretty obvious. We're going to start off with the givens. I'm going to not even write that down. Step number 2, BC is going to be congruent to CE. BC is congruent to CE because that's the definition of a midpoint. Okay, midpoint tells us. All right. By the same reason, I can say CD and CA are congruent, and that's the same reason. And then these are going to be congruent angles. I'm just going to call that angle 1 and angle 2. Angle 1 is congruent to angle 2, and I'm sure you know that by now. They're vertical angles. And then finally, step 5 is going to be that these triangles are congruent. So ABC, triangle ABC, is congruent to triangle DEC. DEC, and that's for reason of side, angle, side. And then finally, like we've done so many times, these parts are congruent. These angles out here, angle A is congruent to angle D because of CPCTC. Alright? Now, last thing we're going to do here really is this Venn diagram one. And if we've got 40 people and they're surveyed about their sports, we've got 3 different groups. You're going to draw 3 different intersecting circles. In the whole universe of our survey, there's 40. We've got 15 out here that say they're going to practice archery, and 7 of them do only that sport. 9 play badminton out here, but all of these play at least one other sport, so there's 0 that do badminton and only badminton. 12 play croquet. This is badminton, this is croquet, and there are 12. And of these, 6 play croquet and badminton. So that means that inside this football shape, there are going to be 6. It does not mean that it's only in this portion of the football, because they might play all 3. We just know that they play these 2 sports. And they say just two people say they play all 3. So I write 2 there and I write 4 there. That tells me that 6 total people would raise their hand if I asked who plays badminton and croquet. Well, once we know that this, let's see, that this is 0 and that's 2 and that's 4 and there's a total of 9 out here, I must have 3 people playing right there, because these are going to add up to that 9 total. Once I know that this is 3 and 2, that adds up to 12, so 3 people have to play here. And then 2 and 3 is 5 plus 4 is 9. This has got to be 3 people out here. So I can fill in those like dominoes, they tip over. I add them all up. The total is going to be 9, 10, 11, 12, 13, 14, 15, plus 7 is 22. So that means 18 people out here play none of these 3 sports. Okay? There we go. This one, I would suggest that you just look at that reading, think about what we did in class, and I'll write down some answers now, but I won't go over it on video. Thanks.